Okay, we're going to do another application of systems of equations, and this is one that's talking about distance and also about going downstream or upstream. So these are two things that you've probably seen a lot in word problems, and so let's go over a few things before we start. When we have a distance problem, we always use the formula distance equals rate times time. Okay, now when we're going downstream, that means that the stream is actually pushing you along. It's helping you go faster. So when you're going downstream, your rate will be the rate of the boat, or the speed of the boat here, plus the speed of the stream. It's helping you along. So I'll put speed here just so everything's the same. Now, when you're going upstream, you're fighting against the current, okay? It's slowing you down. You have to work harder. And so your rate there will be the speed of the boat minus the speed of the stream. Okay, so these are the concepts we're going to use put together to solve this problem. Okay, so our problem says a riverboat travels 48 miles downstream in 3 hours, then 52 miles upstream in 4 hours. Find the speed of the boat and the speed of the stream. Okay, so first of all, let's define our variables here. Let's let B be the speed of the boat and S be the speed of the stream. Okay, so let's take this piece by piece. Let's take the first part. So it says the boat travels 48 miles downstream in 3 hours. Okay, so let's do we're going to have a downstream equation. Okay, we'll use the distance equals rate times time. So our distance is 48 miles. Our rate, since we're going downstream, is going to be the speed of the boat, so B, plus the speed of the stream. And then our time was 3 hours. Okay, now let's do our upstream equation. So 52 miles upstream in 4 hours. So 52 miles. Our rate going upstream is B minus S in 4 hours. Okay, so now we have our equations. We just have to use what we know about systems of equations to solve them. Okay, now let's write them out a little bit easier. So first I'm going to distribute this 3. So I'll write this whole equation here. So 48 equals 3b plus 3s. And for the second one, I need to distribute the 4. So we're going to bring this one down here. Sorry if you can hear extra noises in the background. It's currently storming pretty bad where I'm doing this. 4s. Okay, now there are several ways we could do this. We could do substitution. We could do elimination. We could do graphing. Let's go ahead and do elimination. Let's multiply the top equation through by -4. So I'll just kind of draw an arrow. So -4 times 48 is -192 equals -12b minus 12s. Okay, and let's multiply through the second equation by 3. That way our b's, one will have a coefficient of 12 and one of negative 12. So 52 times 3 is 156 equals 12b minus 12s. Okay, and now we're going to add going down. So negative 192 plus 156 is negative 36. Our b's are eliminated, and we have minus 24s. Okay, so we're going to divide both sides by negative 24. And we get S is 1.5, and this would be in miles per hour. Now we need to find the speed of the boat. So we can use either of the equations. Let's use our first equation. 48 equals b plus s times 3. So 48 equals b plus 1.5 times 3. So I'll distribute that 3. 48 equals 3b plus 4.5. We'll subtract 4.5 from both sides. So 43.5 equals 3b. And divide both sides by 3. We get that the speed of the boat is 14.5 miles per hour. So if we want to write our solution, we can say the speed of the boat was 14.5 miles per hour. And the speed of the stream was 1.5 miles per hour.